I'll give a little bit of a presentation to the panel, of course. Can everybody hear me, by the way, first of all, before we start?
Yes.
Perfect. I've welcome everyone to this panel discussion on the future of artificial intelligence in the context of industrial ecologies. So we're going to look at the opportunities and challenges. In the previous sessions, we saw some of the research that is being conducted on these topics, and on this panel, we will discuss how all these applications and more will take shape in the future, how they can improve sustainability objectives, and what role industrial ecology will have. This event was organized by researchers at Lyon University CML, Ritsumeikan University Hashimoto Lab, and it was supported by Science for Democracy, an NGO advocating for the human right to access and universal enjoyment of the benefits of science and promoting open access and effective science policy interface. We're joined by, well, right now, 3 experts in statistics, sustainability, and digital technologies. If there are any questions, we'll dedicate time at the end of the session. So please feel free to post in the Q&A or in the chat any questions that you might have. Professor Scan Liu is a professor of industrial ecology at University of Southern Denmark, where he leads the social metabolic analytics for sustainability group, a life cycle engineering. His research aims to map the anthropogenic metabolism and inform its circular, low carbon, and just transition through understanding materials and energy stocks and flows and their associated environmental consequences in a system context. He has been awarded the prestigious Robert A. Laudiz Medal by the International Society for Industrial Ecology in 2017. We have Dr. Rohit Nishant, is an associate professor of management information systems at Faculty of Administration Science at the Université Laval, an access leader for emergency information technologies for business at Information Technology and Business Research Center. His research is focused on the use of technology for addressing grand societal challenges, and his research interest includes sustainability, green IS, artificial intelligence, and other emerging technologies such as blockchains to address grand societal challenges. Then Dr. Andreas Frommelt, I hope I'm pronouncing the last name right, is a senior researcher at the Chair of Ecological Systems Design at ETH Zurich. In his research, he investigates the possibility of data mining and machine learning to provide information for advanced environmental assessment, and in particular to effectively support environmental policymakers. Jillian Campbell is who will hopefully will be able to join us soon. She is head of monitoring, review, and reporting at the UN Convention of Biological Diversity, where she's responsible for monitoring of the post-2020 Global Biodiversity Framework, including national action planning. Prior to that, she led the methodological work on the Sustainable Development Goals indicators under UNEP, custodianship and coordinated UNEP's work on environmental statistics and capacity building. So without further ado, I think I have spoken enough, and I'm happy to give the floor to the panelists. So we'll start with Professor Liu. How do you use and envision artificial intelligence and digitalization in relation to industrial ecology and sustainability? It's a broad question, but.
Yeah, first of all, thanks, Franco, and all the organizers to have me here. I think I already attended the session before. I think we heard like 4 or 5 speakers already introducing how they use, AI and digitalization in different industrial ecology applications. So that was also a pleasure. So for me, I divide this question into 2 because you said use/envision. So how do I use? So I think we heard already 2 presentations, at least in this IE day, talking about how we use big data and data mining for lifecycle inventory in RC, which is fantastic. So I myself, as Franco kindly introduced, I'm doing more material flow analysis, stocks and flow analysis. So for me, very straightforwardly, this is a way, to generate, mature stocks and flow data, or let's say data that can, help improve and also quantify mature stocks and flows. I give you a few sort of empirical examples here. First is when we look at building stock characterization, for example, in cities in China, where in general we have lack of data, even for example, building typologies. So, for example, 2 case studies we have published in Environmental Science and Technology, where we basically quantified building environment stocks, in particular for building stocks. And we could not find, building typology data. So, I mean, that's of course very important for also specify, the material intensity per square meters and so on. So what we did there is we do some sort of big data mining for the social media data or the point of interest data, POI data, which of course for big cities like Beijing and Shanghai, where you can already find from other sources. So by using such, whatever you call big data or POI data, we could be able to generate, the types of buildings, so that we can improve, the accuracy of our building stock estimation. So this is just one small example. Maybe also 2 other examples, which we are currently working on. One is they are both for the case studies we are currently doing in Denmark. One is on the building material recognition. So we have an ongoing project which we want to automate a little bit like the building material recognition by combining, for example, the remote sensing, imagery analysis, and in particular, also street view maps. Because, if you think about, when you drive out, I mean, we are using all these kind of search engine and also Google services and so on. There have been a lot of information data already as street view maps or street view imageries, which actually provide a rich source for us to understand actually the materials used in buildings, at least for the outer walls and for the roofs. And if you look at computer science and imagery analysis, there has been a lot of research and models already, developed for not necessarily building materials, but imagery analysis. So we're trying to sort of harness this development and data source, to improve and also speed up our building stock estimation. The same, we can do for building height, because not only in Denmark, but in particular in some European countries, data like the LiDAR data, which you can really harvest and they will generate a building height, and then essentially a digital construction model, which sort of improves building stock estimation. Okay, I think I will stop here for the how I use, and maybe I add just 1-2 sentences about how I envision sort of the role of AI in industrial ecology. What I described are very small implications, more, let's say, for data generation and automation. But I do envision when we combine AI and IE, this really will go beyond data generation, because essentially we can provide a digital twin of the built environment, so we can benchmark and we can simulate actually our physical economy. Because I mean, to me, industrial ecology is really to map and inform our physical economy. So when such tools and intelligence can help benchmark and simulate this physical economy, so then we can actually consolidate and link many accessibility challenges. No matter if we talk about circular economy, climate change, water challenges, transportation behavior, air pollution, also consumer behaviors and so on. So I think that will provide really a very good opportunity to consolidate and also actually a platform for us industrial ecologists to work with researchers from other domains. So I will stop here and give back to you, Franco.
Thank you. Yeah, very interesting. So I give the floor now to Dr. Rohit Nishant to answer the same question.
Okay. Thanks, Franco, for the introduction. So coming from social science, in particular management, so we agree with what's happening. So for example, Professor Ganglu talked about that how this entire flow of data, the data which is increasing and which is used for training machine learning algorithm and artificial intelligence can help us inform about making the physical flow of the processes better. It can help us address the grand challenges. So in terms of the social science research and in management also right now, the focus is on how companies whose supply chains, whose process flow or whose product cash flow is basically responsible for delivering the services and product to the end consumers, how they are planning, how they are actually developing AI systems or machine learning algorithm to capture a lot of metrics to understand how their environmental footprint is. So for example, now companies are investing a lot in trying to measure their direct, indirect, optional emissions so that they are really able to capture what's their total footprint is. They're also trying to use data to understand that the supply chain is complicated. So you can also become green just by outsourcing your dirty production processes to the lesser developed countries. So they are trying to understand what are the way to make sure that really there is a net positive contribution to the environment. So as of now, if you look at the management research and social research, there is a lot of focus on how AI is being used to achieve certain goals in terms of environmental sustainability and also broader sustainable development goal. Now, there is another perspective to it, given the background of social science. There is also focus on unintended consequences. So the idea at the center of unintended consequences is right that industrial ecology is about physical flow, but now data flow is also becoming almost similar in size because of the increasing digitization. Now, when you have the data flow requires energy. It consumes energy. So now the question is that when data flow is consuming energy, so on one hand, maybe AI is being used for uh, getting more data to capture contribution, positive or negative, to environmental sustainability. But what about the carbon footprint of the data flow? Is it some way negating the benefit which we expected from the data flow? So now there is a lot of talk about that. So in social science, there is now increasing focus also on unintended consequences. So that is this notion of data flow itself sustainable? The question, the second thing where there is slight difference between social science and other technical discipline is, so we know that in general, if you ask computer science people, they will say that the more the data you have, that's good for AI because you have machine will learn from it. So the way the technical discipline look at AI and machine learning is they are good for prediction. Whereas if you look at the social science, the focus is more on inference. The idea is to understand the phenomena. So now this perspective is also coming into the social science, that can we have better models with less data? Do we need that much data? Because data means a lot of energy. So is there a way to optimize the data, the number of variables which you are looking at? So there is a lot of talk, a lot of debate going on philosophical aspect of artificial intelligence, because intelligence itself, human intelligence, is multidimensional. So artificial intelligence, since it tries to make human intelligence, what dimension of intelligence do we need? Do we need same dimension of intelligence for every problem, or it has to be contextualized for problem? So moving forward in terms of the vision for AI, there is more and more scrutiny of the unintended consequences. There is more and more focus on how we can make AI, which is more data driven, to consume less data with better outcome, so that the carbon footprint actually is reduced. Then there is also focus on understanding when this is really effective. So real world is complex, right? You can't presume everything will work all the time. There are a lot of contingencies, right? Human behavior is complex. So there is increasing focus on that. So this is right now the view in social science and management discipline. Okay, so this is for the beginning remark.
Thank you so much, Ray. Um, uh, Dr. Frommelt, would you have the floor?
Yeah, well, thank you very much, first of all, for the introduction to join this panel discussion. I'm really excited about it and think it's a highly interesting opportunity. Maybe, well, how do I see digitalization in relation to industrial ecology? Well, as you have mentioned, digitalization and artificial intelligence are very broad fields, but I think if I have to break it down, I would say there are especially two aspects that are important for industrial ecology, and they're very much in line with what Professor Gang Liu already told us, because probably we are both from the field of industrial ecology. Yeah, on the one hand, I see artificial intelligence in the sense of models of using new intelligent tools also for data science. I mean, using intelligent algorithms, for instance, from the machine learning toolbox in order to create highly resolved models, which then, of course, can be used, for instance, to support decision makers. On the other hand, I see artificial intelligence also in all sorts of appliances as another important field for industrial ecology. I think the many smart devices in industry. I mean, we have seen that also in your presentation, Franco, or in our daily lives. I think these smart applications are able to achieve efficiency gains to support us in pursuing a sustainable way of life, or maybe they initiate even some real behavior change. So I think kind of the first area is basically rather using artificial intelligence tools or techniques for models, while with the other one, I'd rather refer to artificial intelligence in real tangible products or energy systems. But of course, these two domains are interconnected, and here, why do I distinguish them? It's also to better introduce how I use artificial intelligence in my current work. I mean, you already mentioned that, and I think just as many other industrial ecologists, I'm especially active in the first of the two areas that I mentioned. So you said that already, that my goal is to investigate the possibilities of advanced mathematical models, and especially of data mining and machine learning techniques to provide comprehensive and highly resolved information basis for environmental assessment. So I basically really aim to create quantitative models that provide tailored and detailed information. And of course, this needs some, I mean, with regard to the huge amount of data, this needs kind of the use of some new and let's say intelligent algorithms. To give you a concrete example, I used huge data sets and machine learning techniques to combine a detailed bottom-up building energy model and an agent-based transfer simulation, but also a very much data-driven consumption pattern model in order to predict the consumption behavior for each individual household in Switzerland. And now in my current research, I use this model also to compute scenarios of the widespread use of autonomous vehicles in Switzerland. So here I'm kind of also basically active in the second area that I mentioned, and I investigate the use of artificial intelligent products such as autonomous vehicles. And I think it's also at this intersection where I envision the future of artificial intelligence and digitalization in relation to industrial ecology. So with, I mean, if we think about all the monitoring and tracking abilities of smart devices or the Internet of Things, just to throw in another keyword, I mean, we will collect a huge amount of data that we have to deal with, and for this, as I said, we will need intelligent algorithms to basically master this big data jungle. And in order to better understand complex systems, this goes in the direction what Professor Nishan said, that we kind of have to better understand complex systems with a focus on inference, and with the ultimate goal, of course, also to improve our models and decision support tools. But I think we should also think the other way around. So I see it also as an opportunity to use intelligent systems and products for implementing our ideas or our maybe new concepts or policies that we develop. And finally, I also think, and this goes again in the same direction as Professor Nishant said, I think we as industrial ecologists will also have a responsibility to assess the widespread use of smart products and support or accompany the design of smart appliances in order to prevent unintended negative effects. But yeah, I stop here because I think it's already more than I was used to say. Sorry.
I know that's perfectly fine. Thank you so much, and I think it's quite interesting to see actually this. I think from industrial specifically industrial ecology perspective, we are very data hungry in a way, right? We're looking for models that can provide us a sufficient amount of details and data that provide us a sufficient amount of details to actually make assessments that we have been having challenges to make. But on the other hand, like the question that also Dr. Nishant brought up is absolutely fundamental. How much is enough? What is the detail? What are the rebound effects at one point of using all this type of data and using these techniques? So I think this provides quite interesting perspective on the two sides. Moving on to the following question. So what are the, perhaps it is a little bit more obvious, but what are the benefits and improvements that you expect from this implementation? We're talking about social repercussions, but also can be technological as you wish. I think we'll take turns. So right now we'll start with Dr. Nishant.
Thanks, Franco. So definitely AI has a lot of potential. So for example, at least at the measurement level, there is still a lot of things to be done. So if you look at the sustainability, when we are talking about carbon footprint, our understanding was very primitive, right? So for example, if you look at the business side of it, so you have Newsweek green ranking, Forbes green ranking, and you see certain bunch of companies which are ranked very green. And then sometimes if you understand the business scenario, then you question that how does it happen, right? So, and it also perhaps reflect about that we were not having enough measurement capabilities. But thanks to the improvement in computing over last few years, now there is increasing talk about how we can use artificial intelligence to create metrics which really capture what's going on in the company. So it's now possible to have breakdown process into subcomponent and then try to find out which are the sources of emission. Is the emission coming from use of purchased electricity, or is it emissions which is directly coming from your processes? Or something which has become important over last year is like many companies are now have, because of the pandemic induced disruption, many people are not commuting, but they are actually working from home. But they are using, like, for example, we are in a Zoom meeting, they are using different tools. So what is the optional emissions? Do companies have these ability to measure it? Where they actually measuring it before? So AI will be quite useful in coming out with these metrics to provide a real picture. So that's to the environmental part. Also about the social part. How do you capture the social metrics? And social metrics are actually more complex because the human element is defined. So how will you capture the well-being of your employee? Because it's physical as well as mental well-being. So there will be a lot of focus on collecting a lot of data to have a better understanding of all these environmental, social facet of sustainability, all facet related to the 17 SDG goals. And this is where I think AI will play a big role. Now, there is also opportunity for artificial intelligence as well in terms of better algorithm development, because now AI will be looking into, so since you are dealing with these complex metrics related to, say, environment and human condition, so you need to have algorithm or you need to have technique which is not black box. So for example, if you have a neural network and you just say that, look, this is the way my results are, but we don't know exactly how it works. At least in business or in management, there will be a less taker for it. And I presume that will also be the scenario in policy, where people would like to know, they will be interested in having AI which can be explained, where you can actually unpack it, what's happening it. So in that respect, I see that there is a lot of potential that as algorithm develop, and we know that a lot of computer scientists, they are working on these things. As AI improves its in explainability, I think there will be a lot of revelation about human behavior, firm processes, which itself will be a kind of a cascading effect to the data which is being generated and measured. So these two together will have a huge positive impact. One, the improvement in the technique, and the second one is the improvement in the data collection. And then we also see the new emerging technologies like IoT, blockchain, which will also bring a lot of clarity on data. There will be a lot of transparency in the data. So I think these three, number one, data metrics generation, number two, AI algorithm improvement, third, we can say that these are supplementary technologies which are already bringing traceability and transparency. Together, these three will have a huge positive impact. This is where we see in terms of the positive impact of AI for a society in next 5 to 6 years.
Very interesting. Thank you so much. Dr. Frommelt,
Sure. Yeah, well, thanks also from my side, because I think I could just agree with your vision. And but let me be a bit more concrete, maybe with regard also to industrial ecology and what benefits do I see here. And I think one was really obvious, which is that we are data hungry and need better and more data. And well, I think I also gave some hints of benefits in my previous answer. So I think the use of artificial intelligence, of digitalization, has especially the big opportunity to collect a lot of data with a lot of highly useful information. And on the other hand, I also think that artificial intelligence is a great means of implementing our ideas. So kind of that we might really effectively have a digital transformation process that induces more sustainable production and consumption. But maybe let me be more concrete. I think industrial culture today is rather on the side of developing models, which is definitely good, and I'm also one of those. And I think actually that there is anyways a big need also that we try to use this new huge amount of highly resolved collected data to improve our models in all our industrial ecology fields, like input output analysis, MFA, LCA, and so on. I mean, if we imagine that, I think with almost real-time data, we will be able to develop models with a high spatial and temporal resolution. For instance, with RFIDs, monitoring sensors, smart meters, we could know how much energy and which materials maybe are used by a specific building or a whole neighborhood or even a whole city. And I'm convinced that we will need this better data or these better models to find and test new solutions and new concepts or new possibilities in order to tackle our grand challenges, like, let's say, the transition of the energy system or creating a sustainable circular economy. I mean, we heard this already in the slot before. And however, I think these ideas and concepts then also need to go back to reality. And here I see, as I said, smart products as an important means that might help to implement new ideas and maybe to eventually bring about change. I mean, if we look at the complexity of our anthropogenic systems, I think we really need artificial intelligence and a certain degree of smartness to help us finding solutions. For instance, if we look at a sustainable energy system, I think we will need to rely on computers and machines that detect specific use patterns, optimize load strategies, balance neighborhoods, integrate renewables, and so on. And maybe even that they come up with specific targeted and personalized recommendations to save energy. Anyways, I personally see a very high potential in micro-targeting and providing tailored, personalized messages that might help us to pursue a more sustainable lifestyle. But these are just examples. I think in short, I consider artificial intelligence and digitalization as an important means to improve our system understanding, to develop new concepts and maybe business models, and then also to effectively implement our solutions that aim to achieve our sustainability goals. Yeah, thanks.
Thank you for this perspective. Yeah, Professor Liu.
Yeah, well, first of all, thanks, Franco, that you rotate us, in answering those questions, because I can see, I agree actually with many very good points the previous two speakers already mentioned. For me, yeah, I put in my answers maybe in three aspects. The first one is a very quick one. Basically, I agree with what we all talk about already. The obvious benefit will be that we can generate data that will be otherwise impossible or in a much slower way. Because, in, for example, industrial ecology or specifically material flow analysis, sometimes we actually admire our colleagues, from let's say Japan or Germany, because they have this kind of data to do this bottom up or whatever detailed analysis. But with some new techniques and AI in particular, we could also speed up and also increase the coverage of our case studies into more areas. So this is, I think, what has been mentioned already. For a second, I want to elaborate. I think this opens really the collaboration between industrial ecologists and researchers in a few other domains. For example, first. Most of this, AI generated or big data has also sort of they are also location specific. So this provides potentially really a spatial dimension of the information that is much needed for industrial ecology models and data, because we have to think really broad and global. But for many actions, or research recommendations, it could be more useful actually when we go more local and actually region or product, whatever specific. So this spatial dimension to me is very interesting. So and also I think that at least for a built environment related big data and AI, it really provides this a channel for us to already not only use the data but also to collaborate with geographers and planners and so on. We can then make more local and spatially specific recommendations. For a second is, it also, facilitates the collaboration with domains, such as like, whatever you call it, like smart or digital planning. For example, again, in the construction sector, there has been a lot of tools, efforts already on enabling digital construction based on, for example, BIMs, the Building Information Management System. This has been already, sort of a established field in the architecture, engineering, and so on. So we can really join efforts. We are also looking at energy issues, embodied emission issues, contaminants in the demolition waste issues, which probably they are interested as well. So of course, for architects and so on, we are probably looking at more the design and architect stage, and we want probably the whole life cycle. But we have very similar interests. So I think this does not only provide data to us, as we are all talking about, we are data hungry, but also actually an opportunity to work with them and actually also cross-disciplinary. So to me, AI and big data are not only a bridge to computer or mathematical or mathematicians, but actually to other domains that actually I would say closer to us, industrial ecologists. Because if you look at the distribution of the industrial ecologists, in many cases we see it in, for example, faculty of engineering, where you probably can find already civil engineers and architect engineers or geographers, planners. Of course, social science, that's also very important. But so I think, yeah, this is just something I want to be more specific. The last point, I think, I think it's a more general point, but I think that's also, to me, very important. We are talking about more data and more automation, and I think this is not something we can with AI and digitalization and also big data, but also that's something we must, because when we think about climate urgency or all these SDGs already, I mean, in 9 years, right? This is 2021, June 2021 already, and we are talking about 2030 Sustainable Development Goals and 17 goals. So we are running out of time, and since we have this booming and emerging amount of data, so that's not something we choose if we want. I think that's a must for industrial ecologists, so we can speed up our research, and we can increase the coverage of our case studies. So we can really fight against all these emerging sustainability challenges. So that's all from me, Franco.
Thank you so much. All three very interesting perspectives, and one thing that I really find interesting is also this connection between being data hungry and using all these different technologies we have a final objective, which is that of solving the many societal challenges that we have, including also the issue of well-being. And even if we are tracking everything, are we actually delivering the proper well-being to people that they need? If we are able to track all the possible bottles, plastic bottles, that's great. But then are those plastic bottles actually providing a benefit to well-being of people? And of course, also the discussion on making sure that things are explainable and artificial intelligence is explainable. That also, I would imagine that it allows, to some extent, also communication across fields. So these are very interesting points, I think. And if you're okay with that, I think we can take a few questions that have been addressed during this last question. And one is on improving models is very important, but do you see any other practical uses? And what are your thoughts on data quality? I think these were to Dr. Frommelt initially.
Oh, okay. Yeah, I actually wanted just to react on data quality. I mean, I think we will discuss challenges later on, right? Because I would have raised data quality definitely. I think I can anticipate here that I think the bigger data is not necessarily better data, right? And I think you have heard that sentence a lot. And I think it's definitely true. It is a key challenge to warrant data quality. On the one hand, really kind of that people that collect data, or also kind of the devices that collect data, they need to have a clear focus on the data quality. But I think it's also the responsibility of the users. And I think I see us industrial ecologists also as very much the users. As we said, we are data hungry, and we have to be critical about the data, because if the data is bad or biased, we will not be able to understand the systems, and then we will also not be able to improve our models. And I think that will be a challenge. And unfortunately, well, good is that you're asking for my thoughts and not for solutions, because solutions are really difficult, I think, here. And with regard to the other one, do you see any other practical uses? Yeah, I mean, as I said, I mean, on the one hand, I would say that making better models is definitely one of the big benefits from artificial intelligence, from big data and all the sensors that collect data. But on the other hand, I also think that it's possible. I mean, what are we doing in industrial ecology? I think we're doing a lot of models that want to try, or that that aim to support decision makers, or to make maybe flows more circular, or I mean, it's a vast a field that we are working in, right? But I think the goal is always to come up with recommendations to achieve our sustainability goals. And I think one possibility, to go back to your question with practical uses, I would say one possibility is also to do to try to implement that either with more efficient manufacturing, for instance, where artificial intelligence is used, or I mentioned sustainable energy systems, because we, as I said, we will need some computer added systems that help us come up with optimal energy strategies. On the other hand, I also could, I think probably the Internet of Things will be another very practical or important practical use, be it on just guiding us towards more sustainable behaviors. I mean, we know already kind of apps that are provided by Greenpeace, WWF, or something like that help us, let's say, choosing greener products and so on. And I think it's difficult to knock out. I mean, it's because it's such a broad field in both ways, in industrial ecology and artificial intelligence. But I hope I could kind of react to your questions, at least in some points.
Yeah, thank you. And we also have another question, but I think this has to, there is more related to the second part of the panel. So this is a question for Dr. Nishant, but we'll address it in the second part of the panel, because it's more related to that part. So moving on, how would you implement your vision? And this time we start with Dr. Frommolt.
Yeah, thanks for giving me kind of the hardest question to start with. No, well, maybe first of all, yeah, maybe I will summarize my previous answers a bit, because what is my vision? I mean, as I said, and I just mentioned it again, I would like to see that we use artificial or intelligent algorithms to profit from the huge amount of data collected by smart products, and in order then to improve our systems understanding, and then to finally improve our models. But based on this, as I said, I also would like to see that we use our, let's say, better solutions that we then can try to implement by means of smart systems and appliances. And I think this is, of course, again, a very broad vision, and there are so many aspects that need to be considered to implement that vision. So I only can pick some examples. Maybe to come back to Tamar Markov's question, let's go to data. Apart from data quality, I think it's also a big questions about data access and ownership. I mean, how can we as modelers access the data? Who's responsible for collecting the data? Who will harmonize the data? So, okay, I'm raising questions again. I know we're discussing this later, but also to anticipate, unfortunately, I do not have a ready-made solution for these questions, but I see actually here promising efforts in the right direction. I see that several countries have open data policies. I mean, first and foremost, the US provides a huge amount of accessible and machine-readable data. Less important for you, but essential for me, Switzerland is catching up and is also putting more and more data online. And I might also here acknowledge the great efforts undertaken by the Journal of Industrial Ecology. I think their commitment to make the data of the published articles more transparent, more accessible, more reusable is really the way to go. So I think open data journals, open data policies is definitely one crucial step towards, let's say, implementing my vision. Another important aspect, especially with regard to models, I also think that modelers need to be braver in applying new intelligent algorithms. I think we should try to leave our comfort zone here, in which we are always using the same modeling approaches, and we should not be afraid of applying new intelligent techniques from the machine learning or data mining toolbox. However, in this regard, I also would like to advocate for a careful and thoughtful use of these techniques. I think sometimes people think that data mining can solve everything and then just apply a couple of techniques. I know I'm a bit provocative here, but I really think it's important that we do not lose good modeling practice and that we keep challenging our modeling approaches. So how can we, so it's not only about data quality, but also about model quality. And I think that's really important. What could we do here? I think one key here is definitely to provide a good education in modeling. But I think in addition to that, to come up with a concrete example, I think it's also important that we have a certain network among peers to exchange questions and ideas. And in this regard, and maybe it's not the right place here, but I don't know, but maybe something like a working group at ISAE could also be introduced, maybe a working group that establishes guidelines for good modeling practice in the field of industrial ecology, but that also could maybe provide a platform for connecting industrial ecologists that apply data science and machine learning algorithms. I mean, these are just ideas, but our new ISAE president, Professor Stefanie Hellweg, the head of our lab, by the way. So hi, Steffi, if you're listening to me. She talked about identifying cross-cutting thematic areas. And in my opinion, data science and artificial intelligence is definitely a highly cross-cutting element with regard to the whole International Society of Industrial Ecology. And I think also it's a possible grounds for collaborations. And finally, I think with regard to my vision, if I may call it so, I would like to see a transfer of our concepts and solutions into practice. And I think this is kind of really the hardest part, to come up with a good solution. I only can give some fuzzy ideas, but luckily this is a panel discussion, so others might jump in. But for me, I think it's really important that we aim to be close also to policymakers and industry. And here I completely agree with Professor Gang Liu that it's not only industry on the computer science side, but also industry who wants to use our models. I think it's really essential that policymakers, decision makers trust our models and are keen on using and implementing them. But I think also if it comes to technical or technological solutions, then we need successful collaborations with industry as well. And here I really can just give kind of very general ideas, like we should initiate more transdisciplinary research projects, more interdisciplinary research projects, maybe also put up more living labs where we can test new concepts and devices. But in conclusion, I think we only can profit from the full potential of artificial intelligence if we try to enforce the links between research, policymakers, and industry.
Thank you. Professor Liu?
Okay, good. I want to respond very quickly to this quality and practical use question first as well. Just one very quick comment on this quality issue. I think we always face this data quality issue, no matter if you use big data or normal data or even pure statistics. The question is rather how you correspond your research question with the quality of the data. So to me, as we were discussing, as a way of generating data that is otherwise possible, I think even some rough and maybe probably lower accuracy estimation could make sense already. When we want to have a first estimate for, I don't know, the stocks or flows or impacts or whatever. So this is just my point on that question. For the question on the practical uses, I actually think for the use of well, at least a compilation of AI and accessibility thing. So we are not lacking practical uses at all. We are more actually learning from the practical uses, because if you look around, I think, of course, it doesn't mean, because there's another question about rebound efficacy, which we will probably discuss later. But I think there are a lot of implications we can look into in practical uses. That either we industrial ecologists can assess or help improve, or benchmark or compare, whatever. So I think we are working actually with those practical uses. So, I mean, just some sort of concrete examples, from my own research, we're looking a little bit at these sharing bikes as well. I mean, this is also very much like a little bit like a data mining and so on, right? it potentially can also reduce the impact from the transportation sector. Not to say in recycling sector, for example, when we talk about plastic waste, there has been a lot of discussion already in the industry. Do we put blockchain technology where we put corners on different types of polymers so you can recycle it better, or even for like aluminum? I think there has been discussion on that as well. Also for critical raw materials or let's say fair metals or environmental friendly metals, there has been also discussion on that as well. Also practical uses. So I think we industrial ecologists are not probably, well, we can, but we are probably not mainly developing new practical uses based on our own research. We are working with those practical uses. Okay, but I think this is somehow linked to the question, the third question of how we can implement this. I put just two very quick sort of thoughts. The first is this does require joint efforts. Not only because we are a very small society, comparing to, let's say some traditional domains, but also because this really requires a lot of resource, human-wise, financial-wise, and so on. So when we identify the areas that industrial ecology can join efforts with AI, so it would be very important if we as a society can also, as Andreas was talking about, maybe use subgroups or committees and so on to really join efforts and to sort of make things quicker or improve the models and so on. I mean, again, using this building environment stock characterization, I just mentioned in my answer to the first questions. I see, in Europe, quite a few countries or some research groups, and also in Japan, other countries, there are ongoing efforts. So it would make sense actually to see how we can maybe joint model, cross-check also whatever kind of remote sensing or high resolution imageries we are using. I think it could benefit a lot. The other thing related to joint efforts is also how we generate the data. In my group, there's a postdoc who has been working on the crowdsourcing, for data. I think it has also a very big potential for industrial ecology related research if we can do some crowdsourcing. When we talk about building, for example, how can actually also implement these kind of technologies by also generating data ourselves from our community, from our research projects, from our research network, and so on. So I do think also crowdsourcing has a potential here as well. The second dimension is multidisciplinary effort. So it's kind of also joint efforts, but more really we need like to work cross disciplinaries. And I mean, practically, or I think there will be different ways. Already, as I said, like within a community, we can form such, or we can at least kick off such a discussion and organize such working groups and so on. But also, we could also reach out to a wider circle, for example, to funding agencies. I mean, there has been a lot of course, funding towards AI and big data as well. How about if we reach out to them and see, how we can combine better accessibility, if not industrial ecology, maybe it's that too narrow to some of the funding agencies, maybe accessibility related research. I think that could be very cool. In Denmark, there's a very good example. There's a private foundation, but also very big foundation called Willem Foundation. They actually started new funding schemes which targets exactly computer science and mathematician and their collaboration with a domain experts. So they fund projects with 2 PI, and it has to be 1 PI from computer science and the mathematician, and the other PI from a domain researcher. And then I see a petition, for example, then we can chip in with industrial ecology / accessibility research questions. But this can also be infrastructure, research infrastructure. So I mean, sometimes we also face already, computation capacity and also data storage and consistency and so on. So for example, and my research institution, we're also doing that, trying to also approach those. I mean, in many universities and countries, we already have those high capacity computation center. And how about if we can also get hold of them and then get some share from our type of research, or maybe our own server, or some types of research infrastructure, because I think when we go towards this direction, we would need something that that is beyond normal laptop style of data storage. So I think that could be also concrete actions we can take. Okay, I think that's my point, Franco.
Wonderful, thank you. And Dr. Nishan?
Yeah. So in the social science discipline or in management discipline, the focus is currently on what happened when AI is implemented in terms of the consequences for society as well as for the businesses. And the things which make our society interesting is also what it makes it challenging, right? So for example, we talk about AI being used to capture a lot of metrics. So for example, now it's possible we can have through Internet of Things or through other technology, we can perhaps try to measure well-being, right? Now, but when you do it in a real setting and when you tell individuals, look, there are technical systems which is capturing a lot of data about you, then perhaps his physical well-being will still be stable, perhaps, but there could be some adverse consequences for his mental well-being. He might not like that situation. So these are the things which are making, so definitely idea to collect metrics is very interesting, and it's now doable, and many applications are focused on that. But as soon as the human element comes, then really the challenge start coming. So taking forward this example, that if you want to capture the well-being, okay, so there is a technical system there which can capture your well-being, but the humans perhaps would not be much comfortable with that idea. Then the next question for humans element will be that who will be owning that data, who will be collecting that data, who is the agency behind that data? Do I trust that agency? Right, we would not like our data to be with a private corporation, right? So there are a lot of issues. Now this makes it even more challenging, because then from a pure AI technical problem, it becomes a challenge regarding data governance, it becomes data ownership, it becomes the challenge of data policies, and then you bring a lot of stakeholders, and there it becomes a truly multidisciplinary problem. And there it actually speaks to what Professor Ganglu and Andreas talked about, that we need to have a multidisciplinary or interdisciplinary approach, because this is not a problem, although AI is a technical artifact at the center of it, but its implication is truly interdisciplinary. There is no one single element to it. Everything has to come together. The other thing which is a challenge with this AI implementation in business is that many times the data which is being generated or the data which is captured is coming from the way our social norms, our processes are already existing. So since you are collecting a lot of data, it can amplify what is negative with our existing social framework. And then there is a chance for machine to actually learn all those negativity. And therefore, we are seeing all these debate about biases, amplifying biases. We have seen these examples. So what we are seeing in terms of AI implementation is, as far as the issue is technical or pure, like for example, environmental metrics, you want to measure emissions, fine. If the process is very technical with well-defined boundary, it's relatively easy to manage it. But as soon as it becomes more like a systems approach where there are a lot of interacting element, then the real challenge begins, and then there is no straightforward answer. So in terms of the research which is going on in management discipline and in social science discipline is still trying to figure out how to manage this situation. And there is talk about, so social science is a wide discipline. There are a lot of there is management, anthropology, sociology, and everybody is trying to bring its own bit. So there is legal element also. So this is right now the stage where we are. We don't have any answer. although this question is very interesting, there is no answer as such. Answers are being figured out. A lot of people are researching, as Professor Ganglu talked about and Andreas talked about. There is very strong recognition that these are interdisciplinary problems. They cannot be just understood, leave aside, resolved through one single lens. So there is a genuine effort. There are a lot of effort from funding agencies to motivate these kind of research, which looks at this problem in totality. So this is right now how things are happening in social science research, but we are still in early phases. These things are coming up. In terms of solution, when we will be able to resolve, I think it's better not to comment on that.
Perfect. Thank you so much. Yeah, I think it's quite an interesting exchange, because we talked about some governance issues and the need for transdisciplinarity and perhaps also connecting also to the discussion on well-being. I think these are definitely quite a lot of interesting points of development. Moving on to the following question, which will probably answer some of the questions that were actually posed also in the chat, and I see some new ones which we'll address afterwards. And it has to do with the challenges, potential risks, and drawbacks of implementations, and essentially what do we need to be careful with as we move forward. And I think we'll probably start this time again with Professor Liu.
Okay, good. Yeah, this is my favorite question, because we do face a lot of challenges, so I can talk a lot. I'll try to make, of course, a bit organized. I think the first challenges is something we were discussing already, that's governance. I also heard this very interesting presentation from I forgot her name, but our colleague from University of Tokyo. I think its governance issues is very important, and I understand from Rohit, this is not like probably solved, and but I think we can still talk about the challenges. For example, infrastructure. I mean, so when we see we are using, for example, street view imageries. Of course, a very important source is from Google. So we are putting a lot of data, big data, spatial data, like a lot of data we are using from those big companies, a handful of companies like Google, and they need actually ask to sign a lot of things, and if you can use it for this purpose, that purpose, is it actually secure to put all the data with just a handful of companies? I think this is really, to me, a very big question, or actually a challenge, or potential risk. Also for data ownership. As I said, I mean, this is probably a question beyond, our panel, let's say, on IE and the AI already. I mean, this has been a big question, also for entire AI field. So who will own the data, and who will get the benefit out of the data or the AI, part of that? I mean, a lot of, for example, is online shopping companies. They are doing this. Intelligence or analysis, based on our behavior. They are targeting very concretely on our needs. I mean, this can, from a accessibility point of view, this can be very good when we turn this knowledge and intelligence into I don't know, accessibility oriented logic. But in most cases, I don't think so. So I mean, they are probably aiming for a profit. So I think this ownership is also a very big question, and this also relates to the privacy issue, which is also really a challenge sometimes when we work with such data. I mean, already even concretely in our analysis for a built environment, for example. I mean, in Europe, we all have this GDPR issue. I heard from some colleagues from Darmstadt in Germany. I think they started some sort of a similar project on a built environment stock acquisition, and then they are not actually allowed to, for example, to assess some data that has name or whatever on. They have to, get the data via some staff from the municipality, and we know, how efficient this can be. So I think a lot of questions of this kind, and what kind of data we can store. When we talk about all this built environment related data, that follow GDPR, and also how we can build on the database. And so I think there's a lot of, unknown or gray area to me. I have a lot of bad experience, towards this. Not necessarily bad, but also it takes a lot of time. For example, when we want to get some energy use data per household, from the Ministry of Tax, at our university legal, advisor probably used half a year really to solve this. I mean, both sides, they want to share the data with us. We want to use the data. We promised we will not, we can sign this confidential agreement and whatever. But still, from a formality point of view, this can take forever. But this applies to many other types of data. So these are just some examples. But I put it very general. I think it's governance and also data security and data privacy issue. The second big challenge I would to highlight is especially for us industrial ecologists. So when we work with people from computer science and or we will work with machine learning, deep learning tools, we don't get lost. So we still always keep the big questions, because industrial ecologists, we are good at asking big questions. When we start to use these models, I think sometimes it can be that we sort of forget a little bit where we start, and then we really go into more like this more technical and modeling issue. I think a lot of us probably have seen this kind of pie charts when you have a three circle, overlapping with each other. When they explain what data science is, when you have like computer science or computer and software science, and then mathematics, and then domain science. So then you can sort of position where you are. Are you doing traditional analytical research? You still have domain knowledge but work with mathematician. Or are you more using like a platform and software? Or are you doing pure machine learning, algorithms? Or are you really, harvesting data science? I think we have to bear that in mind when we, start to, work with such models and also really joint efforts with the AI field. So this is my second point. The last point, which I also think is very important, that can be a risk. So that is with the increased use of AI and big data and so on, we have to pay very special attention to this social/environmental justice issue. First, the data availability is different already, from different fields and different countries, sectors, and regions. And it's very likely that already the industrialized or more high-income regions or sectors, and then we have more data there, and we are trying to probably harvest more data, and potentially this will be of benefit for them more. And how about Africa and Southern Asia and Latin America and so on? So this is from a data availability point of view, but also very important how we use this knowledge, from the AI, how we really harvest, this information from there, so we don't end up, with solutions that actually, further the gap between, different groups and the levels regarding social and environmental justice. A very bad example I recently talked to, actually that's a case in China. You probably heard a lot about this online, food ordering, or this, express deliverable service, which is of course fantastic because it makes your life much easier. You just, when we have a meeting, you just order everything, it will be delivered within half an hour, and all these companies, these I mean, they are also like big data companies, right? They are maximizing, or they are optimizing, where you are, where the need is, and where the supply is, and how this logistics can be optimized. And then, because of the competition, these different companies, they are trying to reduce this delivery time more and more. So for now, for example, in Beijing, if it is more than half an hour, then you go to another company or another app which can promise you, okay, we deliver you within half an hour. And this is not based on AI and a lot of like big data mining. So they really understand this geography, traffic, and so on. And when you are actually competing with each other, nobody is really bearing the cost and really potential risks for those people who are actually doing the delivery, and they are also the potentially more vulnerable people with lower income. They are basically riding motorcycles, and then they are go against the traffic flow because they want to save the time. They don't really pay attention to the red lights because they want to be even quicker. So this AI logistics are actually killing people potentially. So is that something we want to? Of course, this is more for specific applications, but we have many other AI-based apps and applications. Are we going against accessibility? I think that's something we really have to pay special attention to. So with that, I give this back to you, Franco.
Thank you. Very good points. And Dr. Nishant, if you like to take the floor.
Yeah. So I will build on what Professor Ganglu talked about. So one of the major challenge which we see in terms of AI implementation is the trust issue. Now the trust has two parts. It has an emotional part and also it has the cognition part, where people have understand this. Now, over last few years, if you look at it, companies which are capturing a lot of data. So if they are e-commerce giant, so they have a lot of data about how we consume, how we purchase. They are also, many of these companies are actually multi-conglomerate. They also have their own cloud solutions. So if you look at it, they have the cloud infrastructure where they have the data coming from their other businesses, and they are perhaps, so they have a perfect recipe for analyzing this. So they were actually, many of these companies have profited a lot from this digitization, also COVID-induced disruption where we were perfectly online purchasing. So they have a lot of information about it. And data can be used to understand our behavior, to develop a better understanding of our behavior. But now we also see on the parallel side that society as a whole is also becoming aware of what these things are. So there was a time few years back where we were using e-commerce website and we were not concerned. Most of the people, okay, if you are on a say messaging app, you were not that much serious about say the change in privacy policy, but now you are. So the society awareness or that cognition level is also increasing. The other thing which is happening simultaneously is we generally think that government is late to the party. They are the last one to understand that technological development. But now we are also seeing that governments are also realizing that the traditional economy is slowly making way for a digital economy, and the issues of the industrial era is making way for industry 4.0 kind of digital kind of these things. So they are now also understanding what this AI data driven power is, which many of these companies have now. So they are also coming out with legislation. Now, it seems that with proper legislations, citizens will again will be very assured that look, there are frameworks and policies in place to make sure everything works fine. But we know that again, the real world is not as straightforward as right. So there in every part of the world, you see these politics is very polarized. So you have one view and then very strong another view. And depending upon who stands with what political view, they also have a different view on the policies which are being framed at that point in day. So now this makes even more interesting for researcher, but perhaps it's the challenging is that there is still a lot of issues, lot of lack of clarity on how to develop these policies framework, which is consensus driven to manage these challenges which are arising from a lot of data being used for AI by private corporations, which could be used to develop a better understand, in simple term, which could be used to develop a better understanding of consumption behavior, but it has also other uses. So this is becoming a big challenge in terms of trust. How do you trust this entire AI driven approaches? Again, trust is also at the company level. So we see here a lot about data science, and we see data scientists, data engineers working a lot on better algorithm. But at the end of the day, the decision makers are not data scientists, data engineers. They are the one who will simply, who have been used to say pie chart previously, who have been used to say simple cost benefit analysis, ROR kind of things. And suddenly you come out with a very strong prediction model to say that, look, this is how these things will work. And there also then the question is, the mid-level management as well as the senior level management, how will it interpret it? How will it decide on it? How much it trust it? So that's also at the firm level. And then there, as I talked before, there are a bigger issue at the societal level. So if you look at these two things, it's about then the question, which was AI question to begin with, which is a technical question. Now it becomes a very socio-technical question where you have communication, trust, all those non-technical elements, which will actually determine how these things will pan out. So in terms of challenge, we see that these are the things which are going to play a major role. The third thing which will be there is that the data is coming from the society. Society is not idealistic. It has its own reality. So if the data start reflecting the reality, and definitely the data is coming from multiple sources compiled together for algorithm, it will just learn on it. Algorithm is innocent. It will just learn from it, whatever reality is inherent in that data. But we want our society to be moving towards some idealist goal, which is how the society progresses. But then the challenge is society is not currently idealist. The data which is being generated reflect reality. Machine learning perhaps will learn those reality, but we want this to contribute to making our make our society move toward those idealist goal. Now how these things will be actually reconciled? So again, these are the things which will become which are increasingly becoming focus area. So we are hearing a lot about AI bias. We are seeing a lot of examples where some company introduced a AI based agent and then has to withdraw because suddenly they found that it learned something else which it was not supposed to. So these things will become more and more dominant as we see more and more example of that in real life. So I think these are major challenge issues coming from a social science background.
Great, thank you. And Dr. Frommelt?
Yeah, well, I couldn't agree more with my previous speakers here. I mean, and I think I can really build up on that. I would, of course, it will be kind of some repetition because the challenges I think we see are very much in line. I mean, I will not go into the details again with the issues that I see related to data, but of course, I mean, and we already raised these challenges in our previous answers, not only in this round here. I mean, there are problems with collecting, accessing, documenting data, but also, and I would like to point that out, I think it's also about the respectful and ethical handling of it. I mean, that was also mentioned by Professor Gang Liu and Professor Nishant. And yeah, I think that's really important. As Professor Nishant mentioned a couple of times, I think if we do not respect privacy, there will be a mistrust from society. And I mean, it's very likely that the smart devices that are in our daily lives will collect sensitive data. But I think it's not only or this issue does not only apply to data as such, but also to the application of smart concepts and solutions in general. I mean, I mentioned it already that I see micro-targeting and personalized recommendations as an important way to guide us towards more sustainable behaviors. But this means also that we will be influenced by these smart devices to some extent, maybe even unconscious. So here I think a lot of ethical questions will be raised, and I think to really profit from this AI technologies or digital technologies, I think a responsible handling of data and a responsible and ethical development of artificial intelligence will be key. But I also would like to raise another risk that I see is also mentioned in the questions. I would like to maybe emphasize the unintended negative environmental impacts that can occur. I mean, many smart technologies and smart systems are just emerging. This means we do not really know much about them. And I think it's really difficult to anticipate the dynamics if they start penetrating the markets. And I mean, unfortunately, for instance, an initially very good looking idea might backfire at some point. We all know the examples of new business models that first looked like a promising contribution to a sharing economy, such as online marketplaces for accommodation or ride sharing companies. I mean, I will not call the big names here, but I mean, they then turned out to also have unintended negative effects from an environmental point of view. And this is not only kind of in the sense of the concept or the idea as such, but I think it's also digitalization often involves gaining efficiency or saving times. And this is, of course, very intended, but this might also result in time or monetary rebounds. And last but not least, of course, there is also a direct environmental concern with an increased use of smart products that was also raised by my previous speakers here. So, I mean, the mass deployment might use a lot of rare metals, create more e-waste or so, and also the manufacturing and the operation of these smart products, but also the data flows, as mentioned in the very beginning, come up with environmental impacts. But luckily, I think these unintended effects are our daily business in industrial ecology, right? I mean, I think there is no other scientific field that knows better how to assess and anticipate environmental issue in general, which does not mean that we are always successful, but I think it's kind of at the core of what we try to do. And in my opinion, I think here industrial ecology should assume a key role in accompanying a responsible development of applications of artificial intelligence. I think it's also kind of the point where we will not only profit from artificial intelligence, but maybe we can also, let's say, give something back. And yeah, I think it will definitely be key to consider a careful introduction of artificial intelligence in practice. Otherwise, I think the intended benefits of contributing to sustainable goals with artificial intelligence might definitely backfire. Yeah, thanks.
Great. Thank you so much for all these inputs. I think we have exhausted our questions, and I think we can probably move on to getting some questions from the audience, starting from the one that I promised a little while ago, which is related to the digital divide, and I think this was this was addressed to Dr. Nishant. With a risk of digital divide, data might harbor biases and will miss some aspects of the socioeconomic systems that we are interested in. How do you think this can be overcome?
Yeah, I think this is a very good question, that we already see that there is a digital divide as well as data divide, with certain part of the world not having equitable access to the digital technologies, as well as less access to the data. Now, one way to ensure this is my belief, is that the government of the day will have to do a bigger role. These can't be left to the market forces, because market forces will go where the profit is. And in many of these so many of these places where there is a digital divide, now some might say that there is a fortune at the bottom of the pyramid, which has been talked about in marketing literature. But in many cases, I think it will be the government of the day which has to take an approach to make sure that there are people who have access to these digital tools. These has the access to digital tool. One thing which pandemic has shown is that you not only need food, water, shelter. Now internet is also one of the basic requirement, because this has actually kept the economy going. And many people who didn't have that access to high speed internet, they actually were left out. So the government has to focus on this aspect. So for example, in Canada, we are seeing that there is now increasing talk about bringing high speed internet to the rural communities. So that's actually something which now government has to focus on, and this is one way to do it. Now, till the time we achieve that, perhaps one way to make sure is to make sure that data reflect the realities of a society as a whole. We will have to take some kind of a representative approach, right? That you don't just collect the data which is available, means that it's coming from the people who have access to digital technology. It's not, doesn't reflect the society as a whole. So you have to make sure that make use of some traditional mean, or make use of some volunteer to collect data from those part of the society which are underrepresented, to make your data a representative sample at least. And then if it's being used for any purpose, then use it for it. That will be one way to deal with it. It's like, for example, if you just predict election result based on what's happening on tweet, in some countries it might reflect reality, but for example, in many part of the world, you have just 1 or 2% of the people who are on Twitter. So that means if you just form your prediction based on what will these 1 or 2% of tweets, which is a very highly polarized debate going on, you will actually not be able to make sense of what really happening on the ground. And in that case, you find that your traditional psephology, where you go and collect data on the ground, actually works better. So the answer to this solution in the interim period is that you are creating data, you are actually collecting data through digital means where there is no digital divide. You have to supplement it with the traditional approach, which we already know, which comes from statistics, and try to create data manually through the volunteers or through your field agent from those section of the society which doesn't have access to digital tool, and make your data a representative one. In long term, it will again be about equitable access to digital tools and high speed internet. I hope this answers the question.
Thank you. Yes, yes, it does. I'll address the following question to Professor Liu, since he's gonna have to leave very soon. How is artificial intelligence modifying the workflow of science? Do you think? Do you think that artificial intelligence will end up providing better models?
Yeah, meanwhile, I'm also reading this question. I think it's a very interesting question. So, you know, we are of course looking for like more data and you know, better models, and then, you know, but there's you know, there's probably also yeah, sort of a schedule how we, you know, plan this. You know, otherwise there's always like you know, more data. We are not doing that, you know, because we want to just use these more sophisticated models. Because I mean, if you look at this deep learning field, I mean, not probably every day, but you know, every year you see actually better models. You are using this. This can be actually used for my question. Also for data, you know, so you know, new types of data pop up as well. So I would see. I think for us, again, it's very much up to, you know, kind of the question we ask. There's always like a stopping line, and these questions can be asked again and again as well. But I don't think, you know, that's also like the second risk I highlighted. So we are not like getting lost in this sort of data and method field, because I like or not, you know, our industrial ecology field, because we always ask big questions. And we want to put this whole system in the background. So I don't think we will sort of just change our, you know, sort of the loops how we do research. We still probably, you know, propose, at least, you know, to me, I still think, you know, it makes more sense when we have the right questions, and you want, you know, probably that kind of data which is not available or not robust enough from traditional sources, and we are then turning to big data or whatever AI methodologies that can help us, and then or at least help the question I asked for now. And as I said, like the questions we ask can be repeated, and maybe when you ask it again, in 2 years, then you have new models and new data. So just put it very simple. I don't think because of the availability of the big data and the AI techniques, we are changing the way how we do research. I don't think so. It's rather a mean rather than like really a fundamental change of how we do science. So that's kind of my point on this question.
Thank you. Just one other quick question, and then we'll have to close it. But there was also an issue of concerns about negative implication of wide adoption of artificial intelligence in industry. For example, in improving oil drilling, making it cheaper. What are your thoughts, Dr. Fromholt, on artificial intelligence rebound effects in this respect?
Yeah, well, I mean, I thought that, okay, I mean, if it's about drilling oil, I mean, I think it's kind of clear that industrial ecology would not be in favor of that. But of course, I mean, I mentioned that. I think there are a lot of kind of good ideas with regard to improving environmental to improving, let's say, our reducing environmental impact. Sorry, getting tired. I think but at some point it might backfire, and here I think that's really a big risk and a big challenge that we need to keep in mind. I mean, let's come up with maybe with the example also of autonomous vehicles that have a lot of artificial intelligence implemented in the cars, but also kind of in the systems that kind of coordinates the robot taxis or whatever would be the system. And I think on the one hand, I mean, it could be, I mean, there are studies that show that you would only use 3% of the current car fleet, and you could optimize fuel consumption, or maybe anyway switch completely to electric cars with a highly renewable energy system behind and things. So that sounds like a great idea, but on the other hand, I think we also need to keep an eye on what could that initiate, like for instance that maybe population segments that are immobile at the moment would become mobile. So we increase maybe the demand. Maybe people that were going with public transport. I mean, at least in Switzerland, that's usually a clean version of of mobility. Maybe they switch to more of these autonomous vehicles, and depending on what that then increases energy demand, it could backfire again. So I think these are things we have to keep in mind. I mean, artificial intelligence used for, let's say, oil drilling or something like that, I think anyways that industrial ecology would not be in favor of that. So I think I couldn't even think about rebounds here, because it's per se already I mean, that's my opinion. It's per se already kind of nothing that we should improve, but yeah.
Wonderful, thank you. So we are gonna move on to final statements. Professor Yule, would you like to what would be the going home message for us today?
Yeah, so I would put it like this. So we are born in a stage of exploding information and available of AI technologies. So seize the opportunity, and that will be necessary. As I said, that's not something we can, but we must, to address sustainability challenges.
Thank you. Dr. Nishan?
Yeah. So again, building on what Professor Gangliu talked about, so we are living in an interesting time where technologies are evolving very fast. Data flow, it's increasing. I think we have to seize the opportunity, and we just have to make sure that we manage the hype surrounding AI well, and we are grounded to the reality where we don't forget the big picture, that the idea behind all these technologies to make sure that society progresses. So we have to just make sure that these unintended or potential negative consequences, we don't ignore them. We just try to, there will be a lot of iterations. It will be about sometime trial error, finding out that something worked, something might not work after some time. But as science correct everything, we should just stick to the science, basic principles of science, and look at these things dispassionately and try to make sure that we achieve the bigger goal of improvement in social and environmental performance.
Thank you. And Dr. Frommel?
Yeah, well, I think from the industrial ecology point of view, I see artificial intelligence and digitalization as a key to tackle our grand challenges of society and to ultimately achieve sustainability goals. To repeat, maybe on the one hand, I see smart technologies and smart systems might help us to collect a huge amount of data that supports our understanding of complex systems, and then we can improve our models for the development of targeted policies and solutions. On the other hand, I think we will need smart systems to implement our new concepts and new business models. But I think there is still a long way to go. I mean, we saw the many challenges that were raised. And in this regard, I also see that industrial ecology could contribute to a responsible and more sustainable development of artificial intelligence. But I also would like to point out that I think, in my personal opinion, I think artificial intelligence is a key puzzle piece, but I think it's also not the silver bullet to solve all of today's sustainability goals.
Wonderful. Thank you. I'm going to give the floor to Sebastian Dente really quick to provide a quick summary of what we've talked about today.
Thank you very much, Franco. So today we have an interesting discussion. Industrial ecology has a particular challenge because it's providing policy advice for sustainability. So both trying to target environmental and social aspect. And then AI can help on that aspect, because we need more detail and lower grid resolution. That was emphasized quite a lot by the panel, to have a clear understanding of what is happening at the personal level to give better advice and better policy option. But there are still many challenges that we should be aware with the application of the AI. Some challenges are not only related to industrial ecology, but also general challenges related to the use of AI in general, that include the governance issues, the data ownership, and also when we analyze the data, we have to be careful about the difference of access between people. When we make analysis, between the people who got digitalized, who are mainly highly digitalized, and people who are not having access to the internet, and then we need to keep track about like the joint efforts. Like the industrial ecology community should not be alone on that part, but joint effort with people from first the AI, but also from social science, and to get a better view, and to take the words of Professor Liu. It's very important not getting lost when we use this AI model, and then we should try to build also with the. This is still a long journey. We are still at the beginning of the journey, but as we move towards the sustainable application for sustainable science of AI, we should try to find a way to establish good management and good management practice of AI for industrial ecology and for the sustainability in society. Thank you very much.
Wonderful. Thank you so much, Sebastian. So I think we can we will close here the panel. I just wanted to thank, well, first and foremost, all the panelists, especially the Canadian-based ones who were here in the middle of the night for us. The audience, of course, and the organization of the Industrial Ecology Days, Science for Democracy, and the rest of the community that made this session possible. And these are Chen Li, Sebastian Dente, and Xasaita Vilaisok, who have helped, we organized this all together. So thank you so much, everyone, and I hope you enjoyed the talk. And well, I hope you have a great rest of the day and good night as well. Thank you so much.
Thanks for the invitation and for moderating. Thanks.
My pleasure.
Thank you. Bye-bye.
Bye-bye. Have a good
Bye.
day.
Thank you. Bye-bye.